Table of contents. Page 139, graphing rational functions. All right. Here we go. You're going to put this on page 139 in your notebook. We're going to be doing the last of the graphing. Remember, a rational function is a function whose rule can be written as a ratio of two polynomials. You think, I don't even know what that means. It just means there's a fraction and there's a variable in the bottom. There's a variable in the bottom. That's all it means. No. Okay. I hope that you recognize this one. Indeed, that is a parent graph. We have already graphed that sucker. You have already taken a quiz over that. Oh, yeah, you did. You did. Now, so let's see what we remember. Now, I was thinking about teaching this, and I decided I'm just going to have you do it the same way I teach pre-cal how to do it. So, graph and identify asymptotes, domain, and range. Here's what we're going to do. When you graph, you are going to identify the following things: vertical asymptote, horizontal asymptote, x-intercepts, and y-intercepts. That's what you're going to do. So just write those down. A vertical asymptote. Do you remember why in the world you would ever have a vertical asymptote? When you jump and dunk. Well, all right. Now, at the top of your booklet, right up here, you've got space, don't you? A little bit, not a lot. I don't. But here's what you're going to write up there. You're going to write a few things, so don't write great big. You have a vertical asymptote when the denominator equals 0. As long as you remember what it means, you can abbreviate however you want. Now, so let's go down here to this f of x equals 1 over x. So far. Is there ever an x value that would make that denominator 0? 0. Okay. So we have a vertical asymptote when x equals 0. Now, do you remember what the horizontal asymptote for this function is? You remember? Not y equals 1. It's in your notes, but it's y equals 0. Now, the rules for finding a horizontal asymptote we will get to later in this booklet. X-intercept. What does x-intercept mean? When your curve crosses the x-axis. Now, here's what I want you to think about, because we're going to go up here and we're going to write something again in a minute. If I plot points on the x-axis, there's one thing that's common to every dadgum one of those things. What's the y value on every one of those points? 0. So, here's the question. You have an x-intercept when that fraction equals 0. When does a fraction equal 0? When the numerator is 0. So, you have, go up here. You have an x-intercept when the numerator equals 0. What is the numerator of that function? 1. When is 1 equal to 0? Never. This graph does not have an x-intercept. This graph never crosses the x-axis. So you put, now here's what you put, none, none, none. What's a y-intercept mean? Crosses the y-axis. Now, if a graph crosses the y-axis, what's 0? The x value is 0. So, you have a y-intercept when x is 0. So those are the three things I want you to have written at the top. Vertical asymptote, x-intercept, y-intercept, and how you find each of those. You got those three at the top? You will learn about the horizontals on the second page. Now, let's look here. Let's find the x-intercept. When x is 0, what is 1 divided by 0? 0. You can't divide by 0. Undefined. So there is not none. Now we go and we draw in everything from this list. So all I got is a vertical asymptote here and a horizontal asymptote here. That's all I got. Huh? Well, now, so you think, well, all right, that's what I got. Now you're at the point where you say, okay, I've got to plot at least a couple points. So now is where you go and, huh? Because how do I know where the graph is? All I got is 2 asymptotes. That's all I got. Now, here's what you're going to do. You are going to pick 2 points to the right. Shut up. You're going to pick 2 points to the right of the vertical asymptote and 2 points to the left of the vertical asymptote. I don't care what 2 points, as long as they fit. Okay? If we let x equal 1 and 2 and -1 and -2, while I'm answering that, you figure out, well, never mind, I don't have to answer. When x is 1, what's y? What's 1 divided by 1? What's 1 divided by 2? Huh? What happened to what 0? Well, why didn't I put in 0? Because what's 1 divided by 0? It's undefined. That's where I've got a vertical asymptote. And what I just said was, let's pick 2 numbers to the right of the vertical asymptote and 2 numbers to the left of the vertical asymptote. So that's what I did. That's what I did. When x is 2, what is y? 1/2. 1/2. When x is -1, 1 divided by -1. When x is -2. Now we're going to go plot those points. 1, 1. 2, 1/2. That's how I feel sometimes. Aye, aye, aye. -1, -1. -2, -1/2. Oh, you betcha. I'm hoping you remember. There you go. Well, gentlemen, hush. Now, domain and range. Now, yeah, we've already done this. Let's see what you remember. What do you get? What x values can we not use? Where your vertical asymptote is. Range is your y values. That's right. I cannot use y equals 0 because I have a horizontal asymptote there. Now, let's go on down here. Folks, we are not going to graph them, but we are going to identify the horizontal and vertical asymptotes. So, here's what we're going to do. We're going to think, how was this thing transformed? Was there a shift? Was there a stretch? So let's look at A. Left 3, good. That thing goes left 3, so you're going to do left 3. Right. Yeah. Now, vertical asymptote and horizontal asymptote. Now I want you to think about the parent graph. Look, the parent graph is right there, 1 over x. So it's going to be this graph with these asymptotes shifted 3 units to the left. Now, when you shift to the left and to the right, do the x values change or do the y values change? X. So instead of the vertical asymptote being at x equals 0, the vertical asymptote is going to be where? At x equals negative 3. Why does y still equal 0 on your horizontal asymptote? Right, because we didn't go up and down any. Oh, good. Eventually there will be this, oh, yeah. I hope so too, sweetie. B.
Down 3, negative 3.
Up. Well, okay, well, my feelings are hurt, but okay. All right, vertical asymptote. Now let's think about this. Vertical asymptote. Excuse me. I'm going down 3. So let's think. What changes? Does the horizontal asymptote or does the vertical asymptote change when I go this way? Horizontal. And is that x or y? Does x or y change this way? So the y is going to go from 0 to negative 3. So what's going to change? The horizontal is going to become y equal negative 3. And the vertical stays the same. What? Hi, Darrell. Okay.
Right 2, up 1. So then x equals.
Okay, hang on. Okay. Let's talk about the right 2. What does that change? Does that change x or y?
X.
X. So does that change the vertical or horizontal? Vertical. So it's going to be x equals 2. There you go. Now, up 1. What does that change? The y, which changes the horizontal. Y equals 1. There you go. There you go. Well done. All right.
Where?
Huh? Now, there's this thing called, look at the very top of your paper. When do you have a vertical asymptote? When the denominator equals 0. Next page. Here we go. Unlike the graphs we have done before, the graphs we see today will have polynomial functions in the numerator and denominator. This is how we identify horizontal asymptotes, or this is going to change how we identify horizontal asymptotes. Now, you look at the top of your first page. Horizontal asymptotes. Oh, I didn't tell you anything because I told you it was different, right?
Yeah.
Okay. Vertical asymptotes occur where the
Denominator. One of them.
we just did that one. Denominator. Denominator. Snap. I was considering it. Now, you look at this next question right here. What happens when the numerator is 0? Look on your front page. What happens when the numerator is 0? X-intercept. Good. X-intercept. X-intercept. Now, there are three rules for finding a horizontal asymptote. And what you have to do is you have to look at degree. Now, I have a fear that maybe you don't even remember what that is. So, what we're going to do, we're not going to write in here anymore. All I'm going to do is I'm just going to scroll down and get some empty space, and I'm going to help you remember what degree is. So you're done writing in your notebook. What is the degree of that polynomial? Degree is 2. How do you find the degree? The biggest exponent. Put your phone away, Jonathan. Your biggest exponent. What is the degree? The biggest exponent. Now listen. I'm going to tell you, when you are graphing, I want you to always write your equations in standard form. So if we wrote this in standard form, what would be first? Negative 5x cubed. Okay. Now, what about this? What's the degree? The degree is 1. It is linear. Good. What's the degree of this? The degree is 0. Because, well, let me show you. There's no x in it. Look. What's anything raised to the 0 power? What's anything raised to the 0 power? 1. So this is negative 7 times 1, which is negative 7. When you have a constant, y equals 5, y equals 2, y equals negative 8.5, the degree is 0. So when we start tomorrow, we're going to come right back here, and I'm going to say, what is the degree of this numerator?
0.
0. What's the degree of this denominator? 1. What's the degree of this numerator? 1. What's the degree of this denominator? There you go.